This video continues our discussion of Livestock and Climate Change, written by Robert Goodland and Jeff Anhang for the November-December 2009 issue of WorldWatch magazine. Goodland and Anhang raise 5 points, 5 additional sources of greenhouse gases not considered by the FAO, the Food and Agriculture Organization of the United Nations, in their report in 2006, Livestock's Long Shadow. In the previous video, we looked at their first 2 points, respiration from livestock and land use. Just these 2 sources have more than doubled the amount of greenhouse gas emissions which should be attributed to livestock agriculture. But Goodland and Anhang aren't done yet. And in this video, we're going to consider their third point, undercounted methane. So what is this undercounted methane? Methane is important to us who are considering livestock agriculture because livestock are a huge source of atmospheric methane. The more important methane is in terms of global warming, that means the more important livestock agriculture is in terms of global warming. So obviously we're going to be interested in the exact impact of methane. This phrase, undercounted methane, is just a bit misleading because we're not really talking about the absolute amounts of methane that are put into the atmosphere. What we're talking about is the global warming potential of that methane. Methane and CO2, carbon dioxide, are 2 very different greenhouse gases. They have different properties. They last different amounts of time in the atmosphere. And so when we compare them, we have to look at the global warming potential of the methane and not just the absolute amounts. Now, in terms of the absolute amounts of these gases, CO2 is much more prevalent in the atmosphere than is methane. To give you an idea, currently there's about 414 parts per million of CO2 in the atmosphere. But there's only 1,884 parts per billion of methane in the atmosphere. And if you translate that to parts per million, it turns out that about 1.9 part per million of methane is present in the atmosphere. And so that means that there's over 200 times as much carbon dioxide in the atmosphere as there is methane. And that's not all. There's another complication, and that is that methane doesn't last that long in the atmosphere. The half-life of methane, that is, the amount of time that has to pass before about half of all the methane that you put into the atmosphere at a given time will still be there, the half-life of methane is about on the order of a decade. In other words, if you put a given amount of methane in the atmosphere, after 10 years, about half of that methane is still going to be there. So why should we be concerned about methane at all? There's not very much of it compared to carbon dioxide, and it dissipates quickly. And in fact, this is the attitude that a lot of people have about methane. Methane just isn't that important, and we should really focus on CO2 rather than on methane. The problem is, though, that the global warming potential of methane is huge. Over a 100-year time frame, even after allowing for the fact that a lot of the methane is going to be dissipated, the impact of methane is 25 times greater than the same amount of CO2. So whatever amount of methane is put in the atmosphere, you need to multiply that by 25 in order to get the equivalent global warming potential of carbon dioxide. We can consider an example here. In 2019, there were 33 gigatons of carbon dioxide emissions, 33 gigatons of CO2 that we put into the atmosphere somehow. But the amount of methane that was put into the atmosphere is 0.363 gigatons of methane. So you can see that it's almost 100 times greater, the amount of carbon dioxide compared to the amount of methane. But if you look at this over 100-year time frame, you have to multiply this by 25. So you get from 0.363 gigatons of methane, it has the same global warming potential as 9 gigatons, over 9 gigatons of CO2. And we speak of that as the CO2 equivalent. So there's about 9 gigatons of CO2 equivalent. Now this is fairly respectable. It's still less than the 33 gigatons of CO2, but it's getting up there and it's significant. But here's where Goodland and Anhang disagree. They advocate a different time frame, a 20-year time frame for evaluating the effect of methane. If you look at the CO2 equivalent effect of a given quantity of methane over a 20-year time frame, you find out that it's 72 times greater than the same amount of CO2. So in other words, if we were looking at this 0.363 gigatons of methane, that would be equivalent to over 26 gigatons of CO2. So this is really very significant. This makes methane almost as much of a problem as that 33 gigatons of CO2. And that means we're going to have to increase livestock's share of the total global warming problem. And that gives us another 5 gigatons of CO2 equivalents that the FAO has left out. And that explains Goodland and Anhang's item 3, undercounted methane. Now at this point, some people are going to say, wait a minute, 20-year time frame, 100-year time frame, why should we consider the 20-year time frame instead of the 100-year time frame? In fact, it might make more sense to use the 100-year time frame. Aren't we concerned about our great-grandchildren? Shouldn't we actually consider a 100-year time frame instead of a 20-year time frame? Well, there's a problem here. We don't have that much time left before the climate may be propelled beyond critical tipping points because of climate feedbacks. We already have a number of climate feedbacks that are operating, like melting permafrost, which is already happening, and melting ice caps, which is also already happening. Because of these feedbacks, we may be propelled past critical tipping points in the climate. We may find ourselves in a situation in which we have a permanently hotter climate and we can't get back no matter how much we decrease greenhouse gas emissions. Even if we totally eliminate all greenhouse gas emissions, we will be in a permanently hotter world. And we have some experience, or the Earth has some experience in what such a hotter climate might be like. This is the Paleocene-Eocene thermal maximum from about 55 million years ago. Now 55 million years ago is after the extinction of the dinosaurs, when the asteroid hit the planet and wiped out the dinosaurs and about 75% of all other species. This is about 11 million years later. And during the Paleocene-Eocene thermal maximum, the Earth warmed up to about 5 to 8 degrees centigrade over what it is today. And this meant that at the poles, things were actually fairly balmy. We had temperatures like 70 degrees Fahrenheit at the North Pole and the South Pole. And there were swamp animals in Greenland. So things weren't so bad around the poles, but everywhere else on the planet, the climate wasn't nearly as pleasant as you can well imagine. So how much time do we have before we're pushed past these critical tipping points? Goodland and Anhang believe that we don't have that much time, and therefore we want to address these questions now, and we have under 20 years in which to deal with it. But we don't have to take Goodland and Anhang's word for this. The IPCC has issued its own estimates of how much time we have left. In 2018, they said that we have only 12 years to avoid climate catastrophe. 12 years? That's not even 20 years. So really, the time frame should be 12 years instead of 20 years. In fact, please note, this statement was made in 2018. It's already over 2 years old, so really we're talking about a 9-year time frame or even an 8-year time frame. So we don't even have 20 years. We have more like 8 or 9 years before we face this kind of climate catastrophe. I'm not saying that if we don't act by 2030 that we're going to face something like the Paleocene-Eocene thermal maximum, and neither is the IPCC. We don't know that much about the climate. It appears the IPCC, at least, thinks that we are going to face some sort of rather undesirable climate future if we don't act within not just the next 20 years, but in the next 8 or 9 years. We probably don't want to go there and find out exactly what the consequences of our inaction will be. We just need to accept that we need to act, and fairly soon. And so it's the 20-year time frame, or perhaps even an 8 or 9-year time frame, that we need to be thinking in terms of. And here's the real kicker. The IPCC has now altered its estimate of the global warming potential of methane over a 20-year time frame. Instead of 72, it's now 86. In other words, we have to multiply the amount of methane by 86 to get the CO2 equivalent amount of methane. So really, in order to look at this impact in 2019, the total emissions in 2019 of methane, instead of 0.363 gigatons, we should be looking more at the range of over 31 gigatons of CO2 equivalents. That means that the impact of methane and the impact of CO2 is just about the same, and we should be considering them equally. The 100-year time frame for considering methane is just completely unjustifiable. We should be looking at a 20-year time frame, or perhaps even a shorter time frame when looking at the impact of methane. And yet most policymakers and even many environmental leaders are almost completely unaware of these realities. We need to be giving a lot more importance to methane, and that means we need to be giving a lot more thought to the impact of livestock. Once again, we see that livestock and climate change, this article, is actually not wild and speculative. At every turn, livestock and climate change has taken a more conservative approach. That means that the real contribution of livestock on global warming is even greater than that.